And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be upgrading this Commodore 64C to have a Bluetooth joystick port. Let's get into it. Right, let's talk about the hardware we're going to use. This is my Commodore C64C, which has appeared on the channel before. We don't need that because this project is going to be hardware agnostic. Any system that uses a 9-pin Atari-style joystick will be able to use this. So, yeah, I'm not actually going to need the Commodore 64, so I should put that out of the way. Well, we will need a Bluetooth receiver of some description. I choose this 30-pin ESP32 module. It'll work just as well on a 32-pin. So, yeah, you can use almost any ESP32. I'm choosing this one because, one, I have some, and two, they're cheap. So this is an ESP32 dev kit V1. It will do very nicely. We are going to need somewhere plugging it into the Commodore 64. I've got this sort of breakout designed for COM ports here, but all the pins are listed. That'll do to get us started and get a development thing up and running. To go in between the ESP32 and the COM port, we're going to need some kind of level shifter. It's not a COM port, that's a joystick port. We're going to need a level shifter anyway. Now, CIA inside the Commodore 64 pulls the lines up to 5 volts. So sadly, we can't just interface our IOs from here straight into there and pull them low, because this is expecting 3.3 volts. And if we put it up to 5, a disaster will occur and you will damage the ESP32. So we're not going to do that. We're actually going to optically isolate it using these 817 optical isolators. Now these are a little 4-pin device. Let's get one out of the bag. I've got 10 here, I only need 5. So on one side, PC817, there we go. On one side is an infrared emitting LED. We'll never be able to see it because, one, it's infrared, and two, it's inside this black plastic IC moulding here. On the other side is a transistor with no base. The emitter and collector are connected on one side, and the base is driven by light shining on it from the infrared source on the other side. So there is no electrical connection between our ESP32 and our joystick port. Now, that, one, provides a safe environment for our ESP to operate, and two, provides a safe environment so we don't damage the CIA and the 64. CIAs are becoming a little bit hard to find and a little bit expensive, so best we don't blow them up, eh? So yeah, that offers us a nice level of protection and an easy way to switch our joystick port. So that's what we're going to use there. Air-gapped, of course, is going to be our Bluetooth controller. You can use many different controllers. I think the PlayStation ones will work with this. This is an 8-bit Do Pro gamepad, because I am the pro gamer. Oh yes. Obviously we've got a lot more buttons and a lot more sticks than our 64 or any other 8-bit system is capable of supporting. So what I plan to do is make both joysticks work the same, so we can work them with either hand. So up, down, left, right, and I'll make the D-pad do the same thing, up, down, left, right. And I think all the other buttons we can safely implement as fire buttons. So yeah, there we go. That's how it's going to work. So yeah, let's set about having a look at the code. Okay, for our library, if you like, because it's not quite, this is BluePad 32 for Arduino and ESP32. There's a warning here on if you get no output from certain boards, you can work around that. Anyway, these videos, by the way, these are most excellent. I'll put links to them down below. this lady here basically writes this sketch for us. It's very, very easy. So first things first, we just need to go and add the BluePad 32 to our board manager. Now this does describe the older IDE. So if we open up Arduino and go into settings, this is a Mac version. So yeah, it is a little bit different to the Windows and what have you, but you need to find this additional board manager URLs. And as you can see, I've already got the expressive ESP32 JSON file in there. And also, no, we don't need that one. BluePad, there it is. So we have got this Ricardo Quasar ESP32 BluePad URL, and that's from here. So we've already got that installed in our Arduino IDE. So I needn't bother doing anything there. So yeah, and if we go up and have a look in examples, let me just change my board to ESP32, which I will need to plug it in. Right, if we go up here and select our ESP32, I think if we use Do It is the best one. There we go. Do It ESP32 DevKit V1. And as you can see, there are two versions. There's just the conventional flavoured ESP32 version, and then there's ESP32 underscore BluePad 32, which is actually the one we want. So I'm just going to click on OK. If we go up to File, Examples, and then go all the way down to BluePad, which should be here somewhere. Oh, so many libraries in these days. BluePad 32 ESP, there we go. And we want controller. So we'll just load that up. There we go. And upload that to our controller. Okay, our code is now loaded up. So if I go to Tools, Serial Monitor, that'll give us our serial window down here. I'm just going to blow that up. If I hit the EN button, which will reset the board, there we go. Bluetooth stack. Bluetooth, that's that bit. And there we go. Now, at this point, you need to put your pad into pairing mode. And once you've done that, it should pair up. And then if we push some buttons, might work better if I switch it on. I thought we were automatically in pairing. Aha, yep, we are on. As you can see, as I move stuff about, we get various different sensor readings on our joystick there. And if I click up and down, up, you can see D-pad there is changing to 1. Right, 4. Down, 2. And then left there is 8. You can do 2 at once, so we will get 0xa there. So, yeah. So we get a hex value for the bits on that side. On this side we get buttons 2, 1, 4, so 8, 2, 0, 1, 0. We get throttle moving for that shoulder button there, and brake for that one there. Yeah, so what we've got to do is act conditionally on those values and flip a GPIO pin actually high, which will switch our optocoupler on, which will take our collector and emitter and ground our appropriate pin on our D sub. That's the plan. Right. I think the next thing to do is build up some hardware on a piece of perf board. Right, I've just got on KiCad and drawn myself out a quick schematic. I'll just talk you through it. Here is our ESP32 30-pin unit. You could use a 32 pin if you wish. As long as we stick to these GPIOs, you should be okay. Not all ESP32's GPIOs are entirely well behaved, especially at boot. So we need to pick some that sort of are, just to prevent an undocumented operation. So I'll just take you through one of the channels. So GPIO 16 is actually up. That feeds via a 100 ohm resistor into our opto isolator. This is the LED side of it, and this side goes back to ground. So when we take this pin high, it'll switch the LED on, which biases this transistor on. These collectors here are all coupled back to pin 8. Pin 8 on our joystick port is ground. So when our transistor is switched on, pin 1, which is up, then gets connected to ground, and we go up. That's the plan. So we've got up, down, left, right, and fire. Now, I did contemplate powering the ESP32 from this pin 7 5 volts. That gives us a slight problem. One, we've only got a maximum of 100 milliamps, and ESP32, especially on boot, is a bit of a guts. This is likely to draw probably 200-300 milliamps just at boot for the first few milliseconds, which is more than 100 milliamps. So yeah, not ideal. And the other thing is, not all systems have that 5 volt pin. Amstrad 464, for example, doesn't. So it wouldn't work. So what I plan to do, at least for the time being, is just to power it from its own USB port. What we could do, of course, is add one of those little battery charging modules and just a lithium-ion battery to drive the lot, or power it from an external battery bank that we've made before from Street Lithium. So we could do that. Anyway, that's the hardware. Let's build it up. Right, I've got myself a piece of perf board. I've got my ESP. I've got 5 PC817 optocouples, 5 100 ohm resistors, and my 9-way D breakout board there. So first thing I want to do is I want to look carefully at where the pins are. Now, as you can see on the diagram, GPIO 16 and 17 aren't listed on this list of I/O pins on the side, and that's because they're marked up as RX2 and TX2. We're not using that, so I don't have to be worried about that. There's nothing on this side I'm using yet. There may be later on, but we shall deal with that as and when I come to it. Okay, I do want to be a bit careful when soldering this up that I leave myself enough room that I can currently get the USB connector in. So I don't quite want to solder that flat against the board. So what I really need is some sort of spacer, which I don't have, so I shall use a couple of blobs of blue tack there. Get it in to the board so I can solder it up without it looking horrible. That looks about right. I've got a nice warm soldering iron. I've got some very nice solder. And we'll just solder that up. Actually, I'm a pin out there. I want to be a pin closer to the top. We want to give the antenna PCB here as much sort of free air to get into as well, so we get, you know, good reception. If we put it up against a load of copper and stuff, it's going to hamper its reception, which we don't really want. Right, that's looking pretty decent. Let's solder that up. Oh, I think we might just have a little bit of fume extraction. Alright, there we go. Didn't make a complete noise of that. So that's a result. So now we need to position our 5 optocouples. Switch that off. 5 optocouples down this side, and we're going to have to get our 100 ohm resistors in between. Of course, we made this on a PCB. We'd probably be using surface mounted resistors. That I could do on the back of here. You can get 0805 quite nicely between the 2 pins, but there's no point in doing that at the moment. Let's see if we can get a working prototype up together. So RX2 is going to go there, RX3, so they're all going to be sort of bunched up a little bit down this one side here. So pin 1 connects to the resistor, and then back to the prerequisite I/O port. So what's our furthest one? IO21, which is that one there. We can squeeze them all in here. That'll be a win. I think what's needed here is the leg squishing tool. Right, that's our optocouples laid in place. The resistors may be a shade higgledy-piggledy, but it's just a prototype. Let's get those soldered in place. There we go. Not the neatest job in the world. And then between pin 1 and each of our relevant I/O pins on the ESP32, I'm going to start with this fire button down here, which is pin 21. And I'm going to do something naughty and go slightly diagonally across the board, because it's only a prototype. There we go. Get my snips. I'm going to snip the wire just before, because that way it allows me to push it flat against the pad and make that connection to pin 1. Like that. Solder that end in position. Okay, and then onto pin GPIO 21 on our ESP32. Check that with some seeing eyes. There we go. Next 100 ohms. Okay, so that's all our IOs coupled in, ugly style. Now the next thing we need to do is pin 2, they all need to go back to the ground pin on our ESP32 here. So what I plan to do is just run a wire up the back, over to the ground pin, and then connect all those together. So for that I shall need some tinned copper wire. Which I shall connect to ground, which is the second pin down on this side. Let's tin this tinned copper wire up. I know that sounds counter what's it, but this tinned copper wire is probably 50 or 60 years old, and it's not the easiest thing in the world to solder anymore. Oh, I don't know. going to tack it onto the board there. Come around the corner nicely. There we go. Come around the corner and straight down the middle. Right, so that's all our ground points, earthy ends of the diodes connected back up to the ground on our ESP32. So that is good news. Okay, so we've got the output side of our hardware to wire. Now, just wonder if I fix that on and just wire it across or put it on a bit of lead for now. It could go like that, couldn't it? Thing is, it's got to go into the side of the 64. Let's have a look. So you could mount it like a pod if we made a board for it up small enough so it would just fit in. And, you know, you get the ESP32 in some of that sort of length. That would work well. I think for now, it's just going to be a bit of a lead, isn't it? Or do I put it on a bit of a lead? I think for now we just go with this. Right. Right, just for ease of connection here, I've connected in this 10-way Molex KK there. So I just got a wire to the back of that, and then I shall common all the pin, whatever it is, goes to ground. It is pin 3s together when I'm done. So I'm going to need lots of little bits of wire in there. So talk amongst yourselves while I just spin that up. And that's it. So now I can just stick some DuPont wires on there, back over to the D port, just to get it going. And I shall do that once I've had a little poke around the software. Right, coding has occurred and I've had to make a slight change to the hardware during testing. During development, I just used the simple joystick tester that we built a few weeks ago, and that simplified life rather than have to load up a real Commodore with the adapter connected. So that was good. Let's step over into the office and have a look at the code and the changes to the hardware. So this is what I've had to do to the hardware. I've had to drop the value of these resistors to 47 ohms. I'm not very happy about that. In fact, I'm not happy about quite a few things that are going on here. But it is working, so that's good news. Let's just step into the code and have a look at it. So I've chopped out all of the original code that dealt with keyboards and mouse and everything. I've left this dump gamepad thing in here. This just gives you a readout on the serial port of what all the controller functions are doing. It's not actually being called this part at the moment, but process gamepad is. This is the bit I've had to modify. So I'll give you some idea. This is this is the up part of the sketch, if you like. So that says if the D-pad control bit 1 is set there, then then it sends digital write high pin 16, pin 16, switches that optocouple on there, which then connects pin 1 of our D subs there back to ground. We've got some ORs in here. OR control axis Y, which is the left hand stick, is less than minus 200, or the other stick is less than minus 200. So all of the functions there are, so we've got the D-pad, the left hand stick and the right hand analog stick. If that bit's not set, set it low. Same for down, left and right, slightly different values in axis Y and axis RY. Then we've got fire, so if control buttons, if anything other than 0 there, or control throttle is anything other than 0, or brake is anything other than 0, then digital right 21, which is this one down here, switches that opto on, which is pin 6, which is our fire button. So that's how it works. Now down here we've got process controllers. This just sets the controller up. It needs to be a gamepad that the library recognises, and apparently it does recognise an awful lot of gamepads, so yeah, just try it and see how you get on. I've noticed, by the way, that apparently some of the Sony PlayStation sticks, their axes drift a little bit, so you might want to have a look at that and modify some of these values here. I have to say the 8-bit do-pad, when they're in the middle, they seem to return 0, and that's the end of it. Yeah, so if you need to look at what's coming out of dump gamepad, there is a thing where we can put that back in here. Where is it? It's not in setup, it's in loop, I believe. Process controllers. This is all running in CPU 1 because the ESP32 is a dual core processor, so all the Bluetoothy pad things are going on on the other processor. So that, yeah, makes it really good actually. Here's our pin setup, serial port setup. But if you want to update that, just call that dump gamepad, sorry. Add that back in there and you'll see all the data appear in the serial port. So that's that. Let's nip back over to the C64 and see how it performs. Okay, so I've got my Commodore 64 set up. Let's load up a bit of a game, see how it performs. There we go, press fire to start, and it's going. As you can see, we're playing, and the response of it, I have to say, is very, very good indeed. Oh, come on. Ah, quick. No. Stupid game. Anyway, there you have it. Working really nicely on the Commodore 64. However, there is an issue. Right, I've swapped out the Commodore 64 for my venerable Atari 2600. This is a Light 6. And as you can see, it comes up and runs. This is Pac-Man. Allows me to start, but I can't move right. Can't move anywhere. I can't move right. I can't move up. But left and down are working fine. And yeah, suboptimal. And I think the problem lies is there's no actual pull-ups on the joystick ports of the Atari 2600. It's just relying on the Riot chip. And I don't think the optocouples are going low enough resistance to switch the Riot reliably. So we're just on the edge of some tolerance somewhere. So what I need to do is procure some optos that have got some kind of MOSFET on the output. And I think I found something. I'll make a little order and we'll come back in a couple of days.
The next day.
Right, well, it's the following day and I've slept on things a bit and I was just about to order some MOSFET output style of opto. You can actually get them with two MOSFETs in, like little semiconductor relays. Brilliant. But I didn't, because I can't see a reason why this isn't working. So I've done a bit of probing about this morning, and sure enough, left, down and fire are pulling the voltage a bit low, but up and right barely making any difference at all. That's measured on the Atari. I measured the same thing on the Commodore 64 because I know the CIA actually has pull-ups there. But again, they're not pulling very low. Just enough, I think, to trigger the Commodore's CIA, but obviously not to trigger the Riot chip. So, yeah, I got to thinking, why isn't this working? So I went into the garage and I had a poke around in the vast number of spares that are in there, and I found some real, genuine, sharp PC817 optocouples. Fitted those, and would you believe it? It works perfectly. I can go right, I can go up. I still can't play Pac-Man, but yeah, it's just absolutely working as it should do. There we go. So it's working fine. What I have done is I have bought fake optocouples. I find that incredible. But there we go. I didn't buy these from a reputable source. I've broken my own golden rule. I didn't have a big enough order to make up for one of the big suppliers. So I bought these on Amazon, and it turns out they're junk. There you go. They're either rejects or whatever. With the genuine part in, it's working as designed. There you go. So, pleased with that. Works perfectly. Works tested on the Atari 2600, tested on the Commodore 64. I will test it on a VIC-20 and an Amstrad this afternoon. See how we get on with that. But there you go. Thank you very much for watching. Click like, subscribe, do all that rubbish. Well, buy me a coffee if you want. There's a link in the description. I will link to the Blue Pad website down below as well. So if you want to have a go at making one of these, or maybe using a Bluetooth game controller to control something else, all those details are there. Anyway, like I say, thanks for watching, and I'll see you really soon here on Doz's Television Workshop. Cheers now. Bye.